Teaching Maths and Science, the Cross-Curricular Issues. What is cross-curricular teaching? Cross-curricular teaching is where subjects and skills can be combined and taught alongside each other or as one. Topic work or themes have been a popular pedagogy for schools as it allows schools to use one topic to teach and develop many of the subject areas addressed in the curriculum. For example, the topic of space could be used to teach science objectives whilst including lessons around maths, the history of space, the religious and scientific debates, writing a biography of an alien, and creating artistic sculptures of planets and stars for displays, thus teaching many subject skills around one idea for the children to explore. Teaching cross-curricular lessons involves a teacher finding suitable links within the subject areas that ensure content is rich and builds on children's knowledge and understanding, while still achieving the expectations of the National Curriculum Framework. Let's now look at the history of cross-curricular teaching through policy changes and initiatives. In 1931, the Haddow Report inquired into the best teaching methods suitable for primary-age children. It suggested that the topic method can allow children to widen their interest and implement their skills. This was supported by the Plowden Report, which discussed that children benefit from cross-curricular learning during infant school age, however they may gradually move away from topic work as they progress into junior age. In 1982, Cockcroft published a report, Mathematic Counts, that supported cross-curricular teaching of mathematics. The report looked into how maths can be linked with many other subjects, including science, to enhance children's understanding, more so of that of strict subject teaching. The Three Wise Men report in 1992, however, argued against the popular topic and theme work pedagogy in schools, debating that although it may be a suitable time to teach cross-curricular learning, there should be more emphasis on the strict subject teaching. These ideas stem from evidence suggesting standards in core subject attainment had fallen since the Plowden era of topic teaching, and the report expressed that much pupil time could be wasted on so-called collaborative projects and that these are serious weaknesses in classroom practice. However, it is not clear what the evidence the report was referring to. The National Curriculum 1999 was introduced to set out statutory guidelines of content required to teach and raise standards in 12 segregated subjects. It provided guidance for 3 core subjects, English, Math and Science, and 9 non-core foundation subjects through a series of key stages. The document set out programmes of study for each subject and appeared to favour the discrete teaching of subjects, especially the core, although it should be recognised that within the margins of each programme of study were some key links with other subjects. The Rose Review 2009 found that a balanced blend of subject and topic methods resulted in best practice in schools. It also found that using cross-curricular methods complemented the knowledge and attainment taught in more discrete subjects. This review put forward a revised curriculum that further highlights where subject content and skills overlap, making cross-curricular opportunities more explicit. The school's white paper, The Importance of Teaching 2010, set out suggested improvements for a discrete-based new curriculum. However, the paper did later emphasise the importance of allowing for freedom to teach how the teacher feels suitable, ensuring core subject knowledge was gained but with the scope to teach either discretely or in a cross-curricular manner. Finally, the new national curriculum identifies the statutory requirements all pupils need to learn along with some non-statutory guidance notes on how to teach each segregated subject. There is no set guidance for a teaching pedagogy, which may suggest that teaching professionals have more freedom to teach discrete subjects or cross-curricular topics, or a possible balance of the two. In addition, much of the statutory content in individual areas is mirrored with that of other subjects, providing easy links between cross-curricular opportunities. When looking specifically at science and maths, there are many advantages to a cross-curricular method, the first being that the 2 core subjects complement each other in terms of their content and required skills. As you can see, this list names a few of the more explicit curriculum links between maths and science. All these areas require mathematical skill, whether it be basic arithmetic operations, problem solving, or data handling. It is a widespread belief that children cannot grasp the processes of science without mathematical foundations and vice versa. This is supported by Kerry 2011, as he believes that almost all subjects in the primary curriculum require the same skill base to succeed. He explains that every lesson a child gains subject knowledge, solves problems, collects evidence, draws conclusions, and uses symbols, highlighting that what is learned between subjects is different, but how it is learned stays the same. Hendry 2013 discussed that teaching math and science in a cross-curricular method also allows children to cement their new knowledge into practical situations. For example, a class could focus on weight, mass and measure in maths, grasping the knowledge of units and how we can measure them, then apply that knowledge into practical scientific activities, including the measurement of liquids, lengths or time. Another advantage of cross-curricular teaching is the idea that it is a more child-centred approach to learning. Lawton 1997 built on this concept as he believed a less content-led curriculum could further benefit each child. Lawton believed that a more focus of cross-curricular skills and processes would result in children taking a more active, self-led approach to their learning. The concept of project relates well to this theory, as allowing children opportunities to undertake their own projects in science and maths may encourage mathematical and scientific thinking as well as interest and exploration. For example, a Year 2 class were to complete a project around growing their own sunflower. Such a project demanded a secure scientific knowledge of how plants grow and develop and how to collate data within an experiment. After planting, the children would measure the height of their plant, logging the data for a number of weeks. After collecting the data, the groups use their mathematical knowledge to work out averages and predictions of the height, and were then able to present their findings using graphs and charts, creating a complete project presentation to show their peers. When considering the issues in cross-curricular or discrete teaching, it is essential that we acknowledge the possible disadvantages to cross-curricular work. If cross-curricular teaching is to be effective and successful, it is important that detailed and well-prepared planning is in place. Laurie 2011 explains that teachers working with a theme pedagogy often try to plan for subject areas that do not make natural links. For example, planning lessons purely to ensure all areas of the curriculum have been covered. This method of teaching does not embrace the values of cross-curricular teaching as discussed. It is often misconceived that every subject must be included in a topic rather than including only the subjects that give opportunity for inspired learning. It is also recognised that planning for cross-curricular themes can require extensive amounts of time. In addition, planning for advances in development and skills is again considered challenging. Steed 2012 supports this, explaining that formative assessment is becoming more difficult to complete away from discrete teaching. The emphasis from schools and Ofsted on teachers to assess their pupils' attainment and progress is a constant throughout the curriculum. Such issues within the debate favour more discrete subject teaching as they provide more opportunities to test, assess and see progression within the statutory requirements for league tables and successful schools. Within the statutory requirements of science and maths, it must also be noted that unless links are made explicit to children, the learning and understanding of transferable skills may become hindered. For learners to gain the best out of cross-curricular learning, they must be able to adapt their skills between the two subject areas, but also understand how such processes can be applied to ensure the reality and internalisation of skills. Another possible downfall of teaching maths and science as a shared programme may heavily rely on the subject knowledge of the teacher. Secure subject knowledge will allow a teacher to effectively deliver rich and thought-provoking sessions. In many of the reviews discussed earlier, low levels of secure subject knowledge in teachers were argued to be the cause of unsuccessful and irrelevant cross-curricular learning. Teachers are trained to create learning objectives for their lessons to define what they want children to learn. Such practices may present challenges when teaching maths and science in cross-curricular study, as objectives may take on a broader theme. This again highlights the importance of making links explicit for both learners and within planning to ensure the school and the learner are clear about what they want to achieve. The use of ICT within primary education is widely recognised as a valuable resource. Computing in the curriculum aims to teach children basic skills needed to communicate and gain access to better opportunities using ICT in the wider digital world. As technology resources have become more readily available in the home and community, it could be argued that the primary generation today have more interaction and advancement in ICT than ever before. For this reason, it is essential that we provide ample opportunities for children to explore and build on their learning using such resources. One way in which ICT can enhance learning is through the process of data collection. Consider the previously discussed Sunflower project. The class were able to collate their data through spreadsheets and tables created on computer programs. This data could then be represented through the use of graphs and diagrams, also providing the opportunity for the use of ICT. Data logging devices may also support science and maths in the curriculum, providing individuals the experience of measuring temperature, light and sound through a data logging device, which can then be connected to a computer to present the findings. Such programs offer children the learning experience of carrying out practical tests and noticing patterns and results, or how variables can affect what is measured. Data loggers also provide opportunities for children to investigate situations they may not be able to accurately measure without the support of a data logger. Focuses on temperature, for example, may include whether the water in the school pond is colder at the bottom of the pond or closer to the surface. Using a data logger, such investigations can be completed easily and with more accuracy than using other resources. Another use of ICT to support both the conceptual development and key skills for science and maths could be linked with the use of cross-curricular project work. Learners are given scope to research their area of investigation, collect raw data, collate their results, present the results into a graph or diagram, make conclusions and predictions, all transferable skills over the two core areas, then present their findings into an ICT-based format. When presenting their project to parents, the Sunflower project groups had become familiar with a simple presentation programme, allowing them to create a PowerPoint-style delivery of the many aspects of their projects and findings. The opportunity to present on the interactive whiteboard created feelings of pride, confidence, and a secure representation of the skills achieved and exercised across both subject areas. In conclusion, when looking at the issues debated between cross-curricular and discrete subject teaching, it could be argued that a balance of both strategies would be most beneficial for learners in science and maths. When referring to the possible disadvantages, many could be improved with better training to professionals to ensure they know how to plan effectively and hold secure subject knowledge to teach in a cross-curricular sense. When content between the two areas overlap, there is a clear opportunity to provide sessions to use transferable skills. However, reflecting on relevant research suggests there is also suitable times for discrete teaching of the two subjects to take place to ensure objectives are clear and important subject content is not lost. Also, ICT can provide math and science with exciting and interactive scope to use equipment and resources to further their academic and personal learning. If implemented appropriately, learners can use the available resources to work alongside scientific and mathematical processes. Although it should be noted that ICT should not replace the role of the teacher nor the active learner.